All right, so I know a lot of you have already gotten to the point where you're graphing it, which is good because you're going to use that graph as visual representation. So when you do it by hand, you can look and say, hey, this is very close to what I got when I did it graphically. So what is the original equation? So what's the original equation that we have that was given to us? Okay, perfect. And then now I think most of you by now got the perpendicular equation. What's the perpendicular equation? Minus 3.75. Is that what it is? Show of hands if you got that. That makes some sense to you. Okay, perfect. Love it. That's almost all of you. I can roll with that. So now what we're going to do here, right? You already have the graph that can kind of, most of you can show you visually where they should be intersecting. But we're not going to take that as a final answer. We're going to do it by hand and kind of be a little bit more specific in what our results should be. So substitution method, right? The first step is you want to isolate for a variable, but both of these are already isolated for what variable? They're already isolated for y. So I'm going to take this value of y right here and plug it into this equation over here for y. It's already done for you. So just plug it into the other value for the other equation. So now I'm going to rewrite it as 1/4 x minus 3.75 equals negative 4x plus 4. Have this written out. Everyone's doing this with me right now. No matter where you are, do this with me. Somewhere, make some space on your paper. So now, what variable do we not have? So then now we can find a numerical solution for x. Now we can start trying to find out what that exact ordered pair is. So now you have technology in front of you to be able to do the calculations. I don't, per se. So now let's do this. I want to combine all of my x's on one side, so I'm going to add 4x to both sides. So I'm going to 1/4 x plus 4x minus 3.75 equals negative 4x plus 4x plus 4. Moved it on both sides. Hey, oh no, 1/4 is the same as what? What is that as a decimal? 0.25, right? So I'm just going to go, what's 0.25 plus 4? That's $4.25, so 4.25. This 0.25 is like, I mean, a 1/4 is 0.25, like 25 cents. What's 25 cents plus $4? I always think about it like money. This makes it easy for me. So it's $4.25, so 4.25. X minus 3.75 equals 4. And now I want to have my constants on one side of the equal sign, so I'm going to move negative 3.75 by adding it, so 4.25x minus 3.75 plus 3.75 equals 4. So now I have $4 plus $3.75 equals $7.75. And this is 4.25. Now, those that have technology, I don't know what this is. What's 7.75 divided by 4.25? Because that I don't know. So divided by. So now we're going to have a decimal. That I do know. What's the decimal solution for this? What'd you get?
1.82.
So 1.82. What's the number after the 2?
3.
Okay. So we're not going to round it anyway. I wanted to know what it was. So we have 1.82. That is our x value. As we see, a decimal that is not that attractive. It doesn't cut. It's not like a 1.5. This repeats. So I'm going to show you how we're going to utilize this, or how we're going to need to pay attention to this when we get to the point where we check it. So far, all I did was just have both of my equations, put them next to each other. I realized that the first step's already done. They're already isolated. Plugged in one value to the other equation for y. Set them equal to each other and just do basic order of operations to solve for x. So we've done this. We have that. Great. Now I want to solve for y. So now let's solve for y. And the great thing about it is that each equation is already isolated for y, so it makes it even easier for us. So I'm gonna do the one with the decimal just because. So I have y equals, and 1/4 is 0.25, so 0.25x minus 3.75. That's the equation that I want to use to solve for y. And I'm recording this too, so this will be on my blog later on tonight, you need for this weekend. And now I'm going to substitute in my x into my value of x. So y equals 0.25 times 1.82 minus 3.75. So can somebody, what is 0.25 times 1.82? Say it again. 0.455. Now, can I get some yays on this? I don't want to take this one person's answer when 30 of you have a calculator in front of you. That was a very faint yay. So do you agree with him on this one?
Yes.
Okay, cool. Minus 3.75. So what is 0.455 minus 3.75? And those that have tech in front of you should be doing this, not waiting for an answer. Negative 3 point what?
3.295.
Okay, negative 3.29. We'll leave it there. All right, so we have our x and we have our y. One last part is I want to make sure we check it just to see, and I want you to see how it looks when we check it with decimals that we had to kind of cut off and weren't terminating decimals. So now I want to check it. I'm going to pick the other equation now just to go ahead and work with both of them. So y equals negative 4x. It was plus 4, right? Okay. We have our x, we have our y. I'm sorry, I should have put it as an ordered pair over here. So 1.82 and negative 3.29. That's our ordered pair we're going to check. Negative 3.29 equals negative 4 times 1.82 plus 4. What is negative 4 times 1.82? Negative 7.28. That was real faint. I don't know if I trust that one. Somebody else do that for me? Only one person, two people only half answered that. So I don't know if they're,
Yeah.
Okay, Arvin said yes.
Yes.
Cisco said yes. Anybody else say yes?
Yes.
Okay, I mean, come on now, work with me. Now, what is that plus 4? Negative 3.28. Now, as we see, are these exact? No, they're not. But are they very freaking close?
Yes.
Yes, so this checks off. If it's very close, like very close, it checks off. We're good to go. We're working with decimals that we're cutting off and decimals that are repeating. So we're trying to get an answer that's very, very close to what we need when we check it. But with these decimals, they're not going to be exact. That's why I wanted to do this so you can see they won't be exact, but that's very, very close. So this checks off. So now, as you have this, look at this ordered pair. We see it works. This is where your graph should intersect. So if your graphs intersect nowhere near here, that means that you didn't graph it correctly. Because my math is right. I know my math is good. Your graph might not be. So if it doesn't match, check your graph again and see what happened when you graphed it. But that's what we're doing. You want to make sure that you have the perpendicular equation, you've graphed them, and now you've done it by hand for the next two problems after you finish this one.